Hi Year 12, this is the first in a series of 5 videos for the topic of single variable statistics. Our first video is on organising data. Here's the topic outline. We're going to look at organising data, displaying data, measures of central tendency, measures of spread, and then shape and modality. So a variable is any characteristic number or quantity that can be measured or counted. It's also called a data item, and there are 2 types. There's numerical data, and this has a numerical value that can be counted or measured. And then there's categorical data, and this has a quality or characteristic that can be divided into categories. But beware, you can get categorical data that are numbers as well. Now, when we're talking about numerical data, there are 2 types of numerical variables. There's discrete numerical data, and this takes exact values. It's often the result of counting. For example, populations or test results. And then there is continuous numerical data, and this takes a range of values, and it's often the result of measuring, like rainfall or height or temperature. And if you look at this graphically, with discrete data, it looks like this. Whereas continuous data is a smooth line like this. There are also 2 types of categorical variables, and this you may not have covered in junior school. So there's nominal data, and this means it can't be ordered. So if I say what's your favorite color or favorite animal or favorite movie, that's nominal categorical data. And then there's ordinal data, and this is categorical data that can be put in order. So for example, ratings, how much did you enjoy this meal? Or months, or shirt sizes. Here's an example. Classify the following data sets. Children's height. So that's numerical data, and because it's measured, it's continuous. Most popular car color, so that's categorical data. Can that be ordered? No, it can't, so it's categorical nominal. Prizes awarded, so first, second, and third. Again, that's categorical data, but this time it can be ordered, so it's categorical ordinal. And then finally, the number of children in a family. That is numerical data, but we can count that. It's whole numbers, so it's numerical discrete. And when we organise data, we do so in a frequency distribution table. And you've been doing this for a while now. You have your score or your X value here. We can take a tally if we want to. And frequency means how often does it occur. So there are 5 zeros and 8 ones, 3 twos, 2 threes, and 2 fours. And this means the sum of the frequency columns. So there are 20 scores altogether. Now you may or may not have covered cumulative frequency. And this is where we add up, bit by bit, this frequency column, like this. So we move this 5 over, and then we're going to add on the 8, which gives us 13, then add on the 3, which is 16, add on the 2 is 18, and then add on the final 2 gives us 20. Now this number here should match the total frequency column. So this is like a running total. Now, if we have many different data values with low frequencies, it's best to group the data into classes. It makes it easier to manage. There are many different ways to do this, but typically we like to divide into between 6 to 12 groups. Here's an example. These are the number of cars that pass an intersection over 40 days, and you can see that they're almost all unique. I can see a couple of 77s and a couple of 75s, but the smallest number here is 57 and the largest number is 92. So that's a lot of lines to put into a frequency distribution table. So instead what we're going to do is work out the difference between those, which is called the range. So 92 to take away 57 is 35. And we're going to try and find a nice division. And I can see that 5 goes into 35. So having 8 groups of width 5 will be good. And I'll show you why we're going to have 8 and not 7. I know 7 5s are 35, but it starts at 57 and ends at 92. That's the reason. So we're going to go 55 to 60, 60 to 65, and then all the way up to 90 to 95. So our data looks like this.
And instead of having 35 rows that go from 57 up to 92, we now only have 8. It's far more manageable. But if we want to calculate any statistics, we're going to need to work out the class center. And that's just simply the average. We're going to do 55 plus 59 divided by 2, which is 57. You can actually see that really easily as well. So there's our class centers, which we will use in a couple of lessons' time to work out our statistics.
And finally, two-way tables are used to organise categorical data. Now, we've already covered two-way tables in our unit on probability, so this should be a fairly routine question for you. A class of 25 students either own a cat, a dog, both, or neither. 11 own a cat, 14 own a dog, 5 own neither. Draw a two-way table for this data. So some simple subtraction. 25 take 11 gives us 14. 25 take 14 gives us 11. And then 11 take away 5 gives us 6. 11 take away 6 is 5. And then finally 14 take away 5 is 9. Okay, that's it for this lesson. Our next lesson is on displaying data.